All right, good afternoon. This is for my Honors Integrated 1 class. This is going to be for lesson 21.3. Before I get started, I hope everyone's doing all right out there. I did post a second lesson for 21.1. If you haven't watched that yet, I'll post that for Monday. That'll be Monday's assignment. Don't worry about that this week. This is just for 21.3. I forgot that I posted 21.3 homework. So let me just go over the goals for this lesson, and I hope that I can hit them all here. The first thing I want to talk about is I just want to review. I'm going to talk clearer. I want to review the parts of right triangles, and then I want to investigate the hypotenuse-leg triangle congruence, and then after that, I'd like to go back and review perpendicular and distance on the graph or on the coordinate plane. So let me go ahead and just get started with this. So our first goal is to review right triangles. And if you notice, I have a right triangle right here. I'm sorry, I see a glare off of the window. Let me check and see. I hope that's not too bad for you guys. Not too bad. So here I have a right triangle. And the what I really want to stress are the parts of the right triangle. The sides have specific names for right triangles depending on where they're at. The sides that make the right angle, those are called the legs of the right triangle. So from x to y, or length A, x to y, that's going to be a leg, as well as xz. Side xz will also be a leg because these two sides make the right angle. So those are the legs of the right triangle. The hypotenuse is going to be the side that's opposite the right angle. I like to say that the right angle actually points at the hypotenuse, and so I'll just quickly draw an arrow out of the right angle symbol. But again, that's how I remember what the hypotenuse is. And I wanted to review that because the main part of today's lesson is something called HL triangle congruence. And the HL triangle congruence stands for the hypotenuse-leg triangle congruence. Excuse me. And so what we're doing is we're looking for this type of congruence pattern. Now, this only works for right triangles. It's implied that the triangles must be right triangles by the name of the triangle congruence. So whenever I say the word hypotenuse, I'm implying that we have a right triangle. So if I have this type of congruence pattern, I automatically get congruent triangles. Alright, so this is a hypotenuse-leg congruence pattern. Let me just take a second and discuss why this actually works. So, right triangles are unique in the fact that they have an equation that you can actually use to calculate the side lengths. And so, let's just say this triangle right here, we're going to say that this side length is A, this side length is C, and we don't know what this side length is. And since this side is the same length as that side, I can confidently say that that's length A, and this side is the same as that, so I can say that that's length C. And again, you know what? I'm going to call this one, this side length, I don't know, upside down, question mark. Alright, so because these are right triangles, I can actually write an equation here, and I get this length squared plus this length squared must be equal to that length squared. Right? And I can also write this for this equation. So I get my upside down, question mark, squared, that length, plus that length, squared, and that's equal to that length squared. Now I've actually set up the opportunity to use a transitive property because I have two equations equal to the same thing. And so what I can do very quickly is I can now have my question mark squared plus my a squared. That's going to be equal to my upside down question mark squared plus my a squared. Now, both sides of my equations have a squareds, so I can cancel those out. And I'm left with question mark squared equals upside down question mark squared. And I can actually square root both sides. And determine that both unknown sides must be the same length. And since they're the same length, what that implies is these triangles must be congruent because of side, 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 side. So hypotenuse-leg works for a couple reasons. It works because we can make the Pythagorean theorem out of the triangles. We can determine the unknown side lengths, which gives us a side, side, side congruence pattern, or it could even say it's a side angle side congruence pattern. So I wanted to just kind of verify what that was. So again, without the blue marks, we're looking for this type of congruence pattern, a hypotenuse and a leg, and a hypotenuse and a leg. All right, so if I know that if I have this congruence pattern, I know that these and the entire triangles themselves must be congruent. Let me just point something out right here. Hypotenuse leg only works for right triangles. However, side angle side works for right triangles, and not just right triangles. So make sure you understand the difference between side angle side. Side angle side is allowed to have right triangles, as well as angle side, as well as angle side angle. But it doesn't work in the other way. So hypotenuse leg only works on right triangles, whereas the right triangles can be used in the other triangle congruences. So be aware of that. Let's move on to our last idea, and that's perpendicular and distance on a graph. Okay. So a couple lessons ago, we saw that, let's talk about perpendicular. A couple lessons ago, we saw that perpendicular lines, what must be true about their slopes is that they are what we call negative reciprocals of each other. So if I know that I have one slope of a line that's A over B, the perpendicular slope must be negative B over A. Now you can put the negative with the B, or you can put the negative with the A. Oh, I'm having a hard time here today. Okay. But the negative can go either in the numerator or in the denominator. So that's something that you're going to have to keep in mind, because you're going to be asked on a couple questions to determine if triangles on a graph are in fact congruent by hypotenuse leg. So you're going to have to look at some slopes and determine if the triangles themselves do have right angles. I don't want to go too far into that, but I'm trying to give clues as to how to do the problem. Another thing that you're going to be asked to do is you're going to be asked to calculate distance. All right, and so and not just calculate distance, but show that the distance of one triangle is going to be the same as the distance on another triangle. So, you know, if you're counting, and remember, we only need to use the distance formula if we're counting diagonally, right? So if I'm trying to find a diagonal distance, and that means I need to turn this into itself a right triangle. So remember that the diagonal distance, which we'll call C, the diagonal distance is equal to the square root of the horizontal length squared plus the square root of the vertical distance. Now, that's how we're going to calculate the diagonal distance. So I'm just trying to vaguely talk about the skills you need to do the problems in this section. I don't want to work them out for you. Again, I want you to take what I teach and be able to extend it one or two steps further, and hopefully that this is enough information for you guys to answer all of the problems. Again, don't worry about lesson 21.1, lesson 2. That we'll watch that video on Monday. But this is 21.3, and again, it's just an overview of hypotenuse leg. So again, I hope everyone's doing well. I'm going to also post attendance for today. Make sure that you take that attendance quiz so I can mark you present for today. And if anyone has any questions, please reach out through email or the Remind app. I hope everyone, again, is doing well, and I will post the next video guide. I'll actually just watch the next video on Monday. Have a good weekend, everyone.